Thank you so much, everyone, for being here today, for attending the webinar with us today. We are really happy to have all of you here. Again, the Q&A will be the place for you to put all the questions, comments that you have throughout the presentation. We'll come back to it at the end of the presentation to make sure we answer each and every one of you. In the meantime, if you guys want to put your name, where you're from, and what you would like to get out of the presentation today, that would be great. I'll make sure to monitor that as we are going. But for now, let's start the presentation. So thank you, everyone, for attending the Autonomous System Solution, the focus on the 4DV-SIM for the mining industry. We have great presentation to show you today. First of all, let me introduce myself. So Marie-France Lorrain, I've been working in the AV industry for about 10 years now, working on different projects all over the world in the mining industry, but also in the airport industry and trucking and everything that has to do with off-road. I'm really happy to be here today. I'm introducing Valentin. Valentin is the smart part of my brain. I say that all the time. So he's a technical person supporting me today. So Valentin, if you want to introduce yourself, that would be great.
Thank you, Marie-France. So hello, everyone. My name is Valentin Puy-Foucault. I've been for about 5 years working at OPAL-RT on the autonomy simulation team as a sales engineer and as a field application engineer. And I'll be presenting you today the work that we've done regarding mining simulation in 4DV-SIM.
Thank you, Valentin. So we'll start with just giving you a little bit of a background of what 4DV is, what the tool is, what the different set of tools are also within the system. I will go briefly on that. I do not want to bombard you with information too much because I want to leave as much time as possible to Valentin to show you a video, because it's always better to see it than just hear about it. But again, if you have any question while we're going through the presentation, please put it into the Q&A. We'll be more than happy to answer all the questions that you have. So let's start with that. Why virtual testing? So virtual testing is a very important when it comes down to autonomous vehicle technology. It will help you speed up the scenario model building. It will, based on some of the clients that we had, they mentioned that it cut more than 70% of the testing time that they had by doing it with simulation with the 4DV-SIM tools. Then cost saving, reduce the field testing, integration, and onboarding costs. Testing in the field is very expensive, but it's also very challenging, especially if you're trying to test into a mining environment. You need to basically find a mine and find all the different conditions in which you want to test it, which is the weather is not always collaborating with you. So having the opportunity to test that into virtual testing will save you time, energy, and really be able to test exactly what you're looking to test. Risk reduction, so test your edge case without having to damage maybe your vehicle or to push the vehicle to a limit where that could create damage to the vehicle itself, to the prototype. The flexibility where you can reconfigure your vehicle dynamics and sensor in minutes, not in months. Scalability, move from a small scale academic research to industrial grade deployment. And having the opportunity to test your vehicle with more than one vehicle also is very important. We have a tendency to think of virtual testing as testing one vehicle at a time. In the real world environment, though, there is rarely just one vehicle at a time that is into your environment. So this is where virtual testing can really help you. So the 4DV-SIM software suite is a suite of tools especially developed for the 3D real-time and hardware-in-the-loop simulation and instrumented for intelligent system. We will focus today on more of the software testing, but we have some of our experts that are attending today into the group. So if you have any question on the hardware in the loop testing, please put your Q&A there. We'll make sure to address that also as we are going. So 4DV-SIM generate contextualized sensor data. It defines the test environment, development of mobile robot, drones, autonomous vehicle, and AI. Simulate sensor, which will generate contextualized data. Facilitate the test and reliability of embedded system with lower cost prototyping, test and validation under closed condition of your use case, not just a use case, but your use case. Exploitation of the plug-and-play connection with your embedded hardware. What 4DV SIMs bring to the table that we haven't seen in the market, it's the capability to test more than one vehicle, more than one Ego vehicle. Valentin will show that later into the video, but it's not one vehicle at a time. It's not one type of vehicle. It could be all OEMs kind of intertwined and connected all together, where you can see how they will interact. And also ground vehicle and air vehicle. We know that drones have been used more and more into the mining industry. We're not going to focus on that today, but we just wanted to say out there, to put out there that we can also connect the ground vehicle with the drone vehicle if that's something that you have. So basically, the methodology when it comes down to 4DV-SIM, and I'll go briefly on that, is you define your context, use the library of 3D environment that is already in the system, but you can also import any other environment elements that you would need for your business case. Then you upload everything, then instrument with the same sensor, generate emulated from real sensor, the same mode of communication protocol, media and hardware connection as with the real system that you have. Then the interface with the 4DV SIM with the tool, you can do co-simulation if you already have a system that you're using, but you can also do the simulation with the tool, the 4DV tool just add. And then connect your embedded system to your functional digital twin, the hardware in the loop simulation, and then simulate and generate data for real-time simulation for the business case that you have. So the added value that you'll have from the 4DV SIM is generate the functional simulation to quickly provide data of use case, which are difficult to access, dangerous. I like to call it the triple D for people that I see people on the line that might have heard me before. The dull, dangerous, and dirty. So difficult to access, dangerous, and really dirty environment where you can use these virtual simulation to do that. Test and debug your algorithm, the perception, the localization, control, communication, connect instantly your embedded computer from your digital twin to your real system, improve the reliability of your algorithm, thanks to the thanks for the testing, and then generate automatically database and annotate image from the learning stage for your network used by your AI, and develop, test, and improve your user interface. So the software, I'll go quickly on it, then I'll let Valentin kind of explain it more deeper. But the 4DV simulation has 4 different tools that you can connect to that. So we call it the modules. You can pick and choose anything that you need within that. Some people need all of it. Some people just need a couple of them. So Valentin, I'll let you go a little bit deeper into those different modules.
Sure. Thank you, Marie-France. So as Marie-France just mentioned, right, there's a methodology into which we develop the simulation. And so the 4DV editor is the first tool that I'll talk about. The 4DV editor is the tool where a library of vehicles, of environments, of sensors reside. And this is the tool where we put those things together. We put the environment, one or multiple vehicles, we instrument the vehicles, even the infrastructure. Really, sensors are independent in that way. This is why we can do multi-agent simulation. And so in the editor, this is where we create these scenarios. Now, to go further and to customize scenarios, for example, for the mining industry, bringing environments like an open pit mine, certain vehicles like haulers, excavators, we would use the 4DV system designer. It's used to turn a 3D model, essentially a drawing, into a fully physics-enabled system where we define, well, first of all, things like friction parameters for environments, right? So anything off-road related, it's all about this non-ideal, let's say, road surfaces, and so we can define those things in 4DV System Designer. For vehicles, we can define all physical joints, how a vehicle is articulated, and how we can then control that from an external controller point of view. So all those things we define in the System Designer, so that then they become a resource into your scenarios. After we've done that, then I'll go over the system, the 4DV simulator. It really takes this already built scenario in the editor, from the editor, and runs the simulation, generates the sensor data, and communicate it out to the outside world, to your software in the loop, or even to your hardware in the loop, if that's something you've done. The other two tools, the 4DV monitor and 4DV batch, are maybe a little bit secondary, but actually they don't have to be. The 4DV monitor is our tool to visualize the sensor data during runtime, during the simulation run. If you don't already have your own viewer, your own visualizer, we also support ROS, obviously, so you can always use that to visualize the data. But it's a good tool to have for quick debugging of what's going on in your simulations. The 4DV batch tool comes when we want to automate our testing, right? When we don't want to just run one simulation and see what's happening, but we want to run a whole batch of them, enabling some randomization in between each of the simulation runs, allowing for scripts to execute in between to go over the data, the single data, to perform some analysis, so that you can literally just have it run overnight and go in the morning, see what's going on. So those are sort of the full software suite. Now I guess it's time to jump into the demo. I'll just share my screen.
It is, and while you're looking to share your screen, I just want to answer one of the questions that is in the Q&A from Hishan. Hishan, you're asking about the forestry industry. I just want to specify, today we're talking about the mining industry, but you can take any of the industry that you have, any of the environment that you want to test, and apply that to it. We're just giving an example in the mining industry, but everything that we are showing today could be applied to any other type of industry. It was just easier to tell the story by having one industry or one demonstration or one video that we are doing from zero to the full demonstration. But that can be applied. 4DV is specialized in everything that has to do with off-road. So forestry industry is definitely one of those off-road type of opportunities where you can see. So if just to specify that it's not just for the mining, it's just mining was just an excuse, quotation mark, an excuse to tell you the story about what we can do.
The challenges are very similar for those two industries: complex terrain, complex machinery. So yeah, I'll go ahead. Before we get into the demonstration, let me give you a bit of context. In June 2025, Marie-France and I had the opportunity to visit a gold mine in Ontario, Canada, where we observed a fully autonomous mining operation. As you can see on the right side of the screen, this kind of operation requires a dedicated control room, staffed with representatives from multiple companies, multiple OEMs, vehicle vendors, the mine operators, and planners, essentially responsible for the road layout of the site. One observation that really stood out to us was that, as you can see on the left side of the screen, the autonomous trucks are backing up towards the excavator to be loaded. And what we were told was that the autonomous trucks could only approach the excavator from one side, whereas a human driver could approach from either side. And since everything in mining is about efficiency and reduced downtime, we saw that there was a real opportunity here where virtual testing becomes so valuable. Testing and validating behaviors, capabilities in a safe environment, because doing so in a real mine is impossible, costly,
And the second thing that really caught our attention, the autonomy system from one vendor simply did not work with another vendor, another systems vendor. Um, as a result, operators had to physically divide the mine into separate zones so that each fleet could function safely. If those vehicles had encountered each other, they would not have seen each other at all, and safety has to be held to the highest standards. So these limitations are exactly what we set up to recreate and overcome in simulation, as we are OEM agnostics, and all these different systems could be tested ahead of time together. On the right side of the screen, you can see this same situation, a scenario where in simulation where we recreated two trucks or multiple trucks approaching and parking on both sides of the excavator, something that was not possible in the real operation. That was our goal, to recreate the belly of trucks moving through the mine, getting loaded with material and emptying it somewhere else, and then use that environment to possibly test and validate new capabilities that haven't been deployed in the field. So how do we build this? We start in 4DV System Designer, where we import 3D models of the vehicles, environments. We configure their physical properties, their joints, and other parameters so that each model accurately reflects its real-world counterpart. From there, we move on to the 4DV editor, where we lay out the environment with the multiple vehicles, the contextual objects like the rocks that you see in the center of the screen, workers, pedestrians, and other side vehicles. All of this adds realism to the scenario um, and enhance the quality of the simulation. We also place and configure sensors on each truck and set up the communication and simulation logic. Now, walking through the simulation footage, we begin with a camera fly over the mine, where we can see a smaller vehicle navigating rough terrain, and we're showcasing some of the disturbances that we can add to the simulation. In this case, weather variation, rain, fog, and snow, and along with their potential impact on perception systems. We then demonstrate material loading, rocks being picked up and loaded into a truck, which has a real effect on the vehicle's dynamics. On the right, you can see a 3D LiDAR view, in this case from Velodyne, detecting those rocks in real time as they dropped into the bed. Next thing, we highlight multi-agent support. Once again, there's no limit of the vehicles. You can run as many agents as the hardware allows. Sensors can be placed again on all of these vehicles, anywhere in the scene really. Here what we've done is distributed multiple Velodyne 3D LiDARs so that we can get a point cloud view of what's going on, matching with the camera data on the left. And what follows then is a time lapse of all these trucks of the mine in full operation over an extended period of time, trucks being loaded, cycling through the sites, and parking on either side of the excavator. Now, to be transparent, the coordination logic was built by us for demonstration purposes, but this would be the integration point for different OEMs and mine operators that wanted to test these systems ahead of time in a safer environment, receiving sensor data from GPS, IMU, LiDAR, cameras, and then sending back control commands to each of the vehicles. Now, if you already have simulations that you want to reuse, we can co-simulate with 4DV-SIM. Our simulation engine is optimized for real-time performance and isn't the most, and it's not as accurate, let's say, as dedicated vehicle dynamic tools like CarSim, for example. So we decided to implement a co-simulation with CarSim using the FMI standard as an example. We configured a truck model in CarSim, exported it as an FMU, and integrated that directly into our editor using the C++ API, our C++ API. For this demonstration, control signals like steering, speed, and braking inputs coming from a joystick controller are sent to the FMU. The FMU returns at every synchronized time step the vehicle's position. We then apply that position to our vehicles along with the vehicle's sensors, So in other words, 4DV runs the simulation, sends control signals, waits for the FMU's response, and places the vehicle exactly where the physics model says it is. Then the sensor data are generated and transmitted just as they should. And yep, that wraps up the demonstration. Thank you.
So thank you, everyone. That's the presentation again. I put a little note in the chat there because we're doing it through a webinar, through a system like Zoom, or it's the same thing when we do it through Teams or through Google Meet or any other presentation that we have online, because of all the content, all the data that is in there. Sometimes it looks a little bit choppy when we do that kind of presentation, but just want to reassure everyone that the fluidity of the video when you do it on your own computer is way more fluid, and you won't have that choppiness that you might have noticed into the presentation. So that was just a disclaimer that we have this limitation of using the tools that we have online to do that.